Hello everyone. So today in this video we are going to discuss a LeetCode problem which states we need to rotate an array. So let's see what problem statement says. So we will be given an array with name nums and we will be given k. So we need to rotate that array to right by k number of steps. Okay. So what does rotation means in an array? Let's see with an example. Okay. So first we'll try to rotate this array by one step. Okay, not three steps. Well, first we'll see how to rotate this array to right side by one step. Okay, so for this we will create or take one temporary array to see how the transformation goes. Okay, so we have taken one more array. So for example, I is at the zero index and the element store at zeroth index is 1. Okay, now in order to move this array or rotate this array to right side by one step, we will move this one to the second index, that is I plus 1. Okay, so first element we rotated it to right side. Okay, similarly we will rotate all the elements. Okay, so now if we move forward, when I is equal to 1, that is the element value is 2. Now we will move this 2 on the right side and we will store 2. You can see the below array, 1, now 2. Okay, so same way we'll be moving each element on the right side by one rotation or that one step. Okay, so now similarly we will move this 3, similarly we'll move this 4, similarly we will move this 5, similarly we will move this 6. Now but as you can see, now we reached at the last index. Okay, now for example, if we want to move this 7, okay, now where we will move? There is no array on the right hand side of this. Okay, like array has been ended. Okay, so in order to move this, we will place this element at the starting index. We will place this element in the starting index. Okay, so you can see the below array. Now 7 comes at the starting and all the elements are rotated or shifted by one place on the right hand side. Okay, so how to calculate, like when we reach the end of the array, how we decided that we will store that element at the starting index, that is I plus 1 modulo the length of the array. Okay, so in this case the I was 6 and 6 plus 1 7 and 7 modulo by 7, that is the length of the array. So we found that we need to store that array at the 0th index. Okay, now after rotation by one step, okay, the array becomes this. Okay, now we have rotated all the elements to one step on the right hand side. Okay, but in the problem statement it said that we need to rotate that array by k is equal to 3 steps. Okay, so in order to rotate this array by 3 steps, we will do the same thing. Okay, so for 1 which is at 0th index, we need to move it 3 indexes further. Okay, so you can see below array that is on green color. So we will move I is equal to I plus 3. Okay, similarly we will move forward and iterate the whole array by I plus 3 steps. Okay, okay, so let's see the algorithm behind this. Okay, so in order to solve this, we are taking one extra array, that is a temporary array, and for calculation of the index or rotation, we are using this formula I is equal to I plus k, that is the number of steps, modulo size of array. Why we are doing the modulo? Because once we reach the end of the array, we need to calculate the next rotation, but we should not get the out of bound error. So we are doing this modulo of size of array. Okay, and at the last, once we have completed all the transformation, then we will copy the whole content from the temporary array and paste it into the main array. So this will take require extra array to solve this problem, but we can also solve this problem without using an extra array. Okay, so let's see the algorithm how to solve this problem in a single array without taking an extra array. Okay, so first thing is, initially we will calculate the size k by k modulo n. Okay, why we are doing modulo n? Because we are handling a case where the size of k is greater than equal to n, that is the size of the array. So basically in this algorithm we will do 3 reversal. Okay, first we will reverse the entire array. Second step, we will reverse the first k element uh, of the result of the reversal of the step 1. Okay, so step 1 we will reverse whole array, step 2 we will reverse the first k element, and the step 3, that is the final step, we will reverse the remaining n minus k elements. Okay, let's see this example using illustration. Okay, so initially we are taking the same array 1 2 3 4 5 6 7. Here requirement is we are given k is equal to 3 and size of the array is equal to 7. Okay, so first we will calculate k, that is k modulo n. So 3 modulo 7, it will give us 3 only. Okay, now step 1, what it says is like we need to reverse the entire array. Reverse means like we will make everything reverse of this. Okay, so we are given array 1 2 3 4 5 6 7. Now if we reverse this array completely, the array will become 7 6 5 4 3 2 1. Okay, so we have completed the step 1, we have reversed the whole array. Okay, what the steps 2 says is like we will now reverse the first k elements. Now what is k here? K is 3. So first 3 elements that are 7 6 5. Now if we reverse this 7 6 5, it will become 5 6 7. Remember, we will not touch the other elements. Okay, we will only reverse the first k element at step 2. Now coming to the final step, step 3. Now we will reverse the remaining n minus k elements, that is 7 minus 3, that are 4 elements, and we will get the final output as 5 6 7 1 2 3 4. So this is the final result which we wanted. Here is the final array which have rotated k is equal to 3 steps on the right side. Okay, now this is the final array after k is equal to 3 rotations. Now let's look at the code part of this. This is very simple. Initially we will calculate the size of the array, n is equal to nums dot size. Okay, then we will calculate the k, that is k modulo n, to handle the case where k is greater than equal to n. Okay, now step 1, reverse the entire array. Then we will use a reverse function in C++, nums dot begin nums dot end. We have given the starting index and an end index of that array. It will reverse the whole array. Coming to the second step, we will reverse only first k elements. Now we will give the starting index as nums dot begin, but ending index we will be giving nums dot begin plus k, that is the first k element. In the final step, step 3, we will be reversing the remaining k element, remaining n minus k element. Okay, so we are again calling that reverse function, and we'll be beginning our index from nums dot begin plus k, that is from k to the end of element, that is the remaining n minus k element, and this will result in the array after n number of k number of rotation on the right hand side. Okay, hope you like this video. Thanks for watching.